Well, hello, fellow spiders. This is Dr. Eugene Wu of the Department of Biology. I'm here to drop a little science knowledge on you and describe to you the coronavirus pandemic and what it has to do with your life as a member of the university community. I'm going to start off with a question: what is coronavirus? And coronaviruses are small little particles that have a nucleic acid genome, like here, and they're surrounded by a little shell made of proteins and some lipid molecules, or like kind of fat molecules. So over here on the right side, you see little images of coronaviruses from a textbook that I use for my class. They are extremely small, but they're real things, little tiny particles. They're so small we can't even see them using the most powerful light microscopes available to scientists. We have to use a specialized instrument called an electron microscope in order to see them. They're very, very small. Here's a picture of a student at University of Richmond operating the transmission electron microscope downstairs in the basement of Gottwald. Here's Brian Dwyer, who graduated just a few years ago, and he's looking at a virus on the screen that is 1/10 of 1 micron, or 1 micrometer. You can imagine my fist. You can fit 1,000,000 of those viruses across the width of my fists. All right, and again, maybe that's hard to imagine. So I have a pretty thick head of hair, and my hairs are really, like they're very thin, but you can fit 1,000 coronavirus particles across the width of a single one of my hairs. That's how small it is. All right, so again, what is coronavirus? Well, let's first talk about the genome of the virus. And the genome of the virus is really just a long stretch of nucleic acid letters like A's, T's, G's, and C's for DNA. And they carry the instruction set for that virus, the code that is necessary to essentially get the virus to reproduce itself. For this particular virus, it's not actually like DNA. It uses something called RNA. What's the difference between DNA and RNA? So DNA is simply the same thing as RNA, except there's one missing atom in DNA versus RNA. So DNA is this deoxyribonucleic acid, meaning that it's missing this one oxygen atom at the 2' positions. That's a small distinction, but it actually makes the DNA molecule a much better storage device for the genetic code, because it's much more stable. All right, so here in the diagram, I illustrate how RNA actually has a tendency to cleave itself into little bits, okay? Over time, given enough time, the RNA molecule, because it has this 2' oxygen atom, that 2' oxygen atom can actually participate in a chemical reaction that breaks the RNA into little bits. So RNA on its own is kind of unstable. Coronaviruses are pretty special in that they have this RNA as a genomic material to pass on its genetic information.